Thank you. Good afternoon, everybody. I suspect everyone's feeling a little bit exhibition weary as well, but many thanks for coming along. I'm going to start off by saying a little bit about the company. You can see where we are. We're right in the middle of the UK. We're about 20 kilometres from Birmingham, right in the heart of England. So briefly, a quick overview of the company. We've been going since 2008. We're a small, successful, profitable business. And as I said, we are right in the middle of the UK. And our specialist skill, if you like, is we manufacture and make and design optical coatings for a wide range of purposes. We are ISO 9001 accredited and have been so for a number of years. And we regard ourselves as a small, agile, easy to talk to company. So we answer emails, we do a lot of Zoom and team calls with our customers, and we always pick up the phone to people. We're always happy to help you out. And our strapline is we want to make your detection dreams a reality, okay? Sometimes it's not always easy, of course. So this talk is primarily about infrared. I look around the exhibition hall and there's an awful lot of emphasis on visible coatings and visible filters, but infrared is slowly gaining more recognition as a potential solution to some problems. Okay, and in particular, I'm going to talk about narrowband filters as well and how they can help solve some of these issues that we are all wrestling with. So, a quick overview of where we are in terms of the spectrum, and if you remember, the visible is roughly 400 to 700 nanometers. The infrared is basically anything the other side of that, just stopping short of the microwave range. So at Vortex, we tend to work in the range between 900 nanometers and 5,000 nanometers. So a quick overview of what an infrared filter does as well, or any filter for that matter. Normally in any system there's a light source and it's kicking out light of all sorts of wavelengths, and the purpose of the filter is to give us this useful bit of light, the bit that we want to do some work with, and normally that is focused onto a detector as a key enabling part of any optical system. So I said at the beginning that infrared, I believe, has got quite big potential, and I'm going to give you some examples of why I believe that is the case. And the first one I'm going to consider is this idea of using infrared filter technology to sort plastics. So these are the common plastics in use, so I'm not expecting anyone to read all that, but like many of us, we're forever putting these plastics in our bins, ready for the recyclers to take them away and try and do something useful with them. So the problem that probably many of you realize is that in the visible, they all look the same. I mean, I've got 2 bottles here, and who knows what materials they're made of. And when you measure them as well, in the visible, they look the same, okay? That's 2 of the different types on the slide, and you can't tell the difference, okay? However, if you go into the infrared and measure them over those ranges, there are huge differences there, okay? And whenever somebody sees these huge differences, that is an area where to position your filters. So for instance, that area there, that's a great position to put a filter to differentiate between those materials, because you've got high transmission of one sort and quite low transmission of another. That's another good area as well, okay? That area to the left, which is getting down towards the visible, not such a good area. There's hardly any difference there at all to use to identify these materials. So that's the guiding principle that we're talking about here. And this is a typical filter that we use to do this sort of thing. Over probably the last 10 years, filter technology has improved massively, and sort of filters that we were only able to dream about maybe 10 years ago, we can now make very reliably and very, very accurately using modern deposition technologies. So it means that quite often we can adapt systems that are currently being used to be able to identify plastics. So in a plastics recycling factory, you'll see a conveyor belt which is ferrying all the recycled plastics from our bins past an optical system like this. So you've got the light source on the left-hand side focusing down onto the material, which reflects light through a filter wheel. And the filter wheel is the key part, because you can make a whole suite of filters to put in that wheel that enable you to differentiate between the 7 types of plastic and other plastics as well. Of course, that's not the whole picture. We need good electronics and good software as well to be able to completely make an instrument for this. Moving on then. So what I'd like to sort of take away, or what I'd like you to take away from this, is an amalgam of modern filter technology combined with a mature technology involving filter wheels is quite an attractive solution for plastic sorting. There is competition though. I mean, you know, you only need to look around the hall. There's a lot of talk about Raman spectroscopy, multispectral and hyperspectral imaging as well. But the more traditional filter wheel technology has got a number of little inbuilt advantages, and I'll run through some of them now. The first one is it's less expensive to do. The filter wheel technology has been in existence for 50 or 60 years, so it's well known, it's bulletproof, it's suitable for a factory, okay? And it has got a long-standing reputation because of that. It's reliable and it's repeatable as well in these applications. It's also faster, and the reason why it's faster is because it generates very little data. So one of the things about hyperspectral imaging is it generates huge amounts of data that have to be stripped down to a few of the essential components in it. So moving on then, the sort of examples of other areas where we're involved in as well. Again, it's all to do with infrared spectroscopy, gas analysis, fairly mature application there. Checking for adhesives. Most adhesives are transparent as well, and just checking around a package to see if it's sealed properly. Fairly lends itself to infrared technology. Measuring the thickness of certain materials, that can also be done using IR filters. Some of the newer areas, identifying crop pests, flying a drone over a farm to survey, what might happen in future. You're looking to identify problems early so that the farmer can do something about it. Medical applications, particularly de-skilling the diagnostic analysis of certain medical conditions. Food security, is that olive oil that you've just paid a fortune for really, you know, virgin olive oil, or is it some cheap import alternative? And widely used in industrial processing applications as well, and things like ingredient mixing in food manufacture, making sure that the ingredients are combined properly. And the last one is, this application is particularly important for putting sell-by dates on goods, where we would monitor the moisture and the fat content throughout a production process. So I guess the final takeaway from this is when you're designing an instrument, talk to the filter manufacturer fairly early in the design stage. They've got a lot to add to the process. They usually have got a lot of expertise and knowledge, and they're useful in terms of being able to give Spectra advice on the areas to exploit, okay? And, you know, a lot of filter manufacturers work with camera and detector suppliers, so there's a lot of market knowledge there as well that could be useful to an instrument designer. And particularly ourselves at Vortex, we're quite adept and quick at making prototypes. Usually in the early stages of a project, there isn't tons of money floating around. You're interested in proving a concept and, you know, trying to get an idea off the ground. So, you know, a company like ourselves will be able to help you there. And that's it. We've been on stand B88 next door all week, and there's only about 2 hours left, but my email address is up there as well. So if you've got any applications or any detection dreams that you want to make a reality, drop me an email. I've got a few minutes left, and I'm happy to answer any questions now as well.